Good afternoon, everyone. I'm very happy to be here. As Matt alluded to, I was sitting in Denver waiting for my Lincoln plane last night, and you get that dreaded announcement, it's cancelled. So I just had a lovely drive over from Denver, and some might see that as a bad luck thing, but actually I really enjoyed looking at the country, and there was some beautiful cattle there. I've never driven across that part of Nebraska, so I found it to be quite a good opportunity. So it was worked out best in the end, and I luckily didn't run into any tornadoes, which I guess there was a lot around last night according to the Weather Channel. So I'm going to be talking a little bit today about a project that I've been involved with called the California Commercial Ranch Project, and it's somewhat analogous, I guess, to the weight trait project in terms of what we're trying to achieve, only in California. And the overall objective of this project was to develop a genotyped, phenotyped commercial population of animals to use for basically looking at validation of some of the tests and different genomic approaches that are being used to do genetic predictions in the beef cattle industry, and with the idea that it will develop a range of these resource populations here in Nebraska in different environments that we can use to have a look and see how well things are working. And so it's a USDA project, and the research objective was to have a look at the current means of genetic prediction for herd sires, which is basically breed association EPDs, and have a look how they perform relative to DNA-assisted genetic predictions, and then also commercial ranch genetic evaluations based on the actual performance of those herd sires, or progeny test, if you will, in field conditions. So it's a collaboration with commercial producers in California, and so we work within the constraints of their ranch and using their particular production style. And an additional objective and a particular interest of mine is having a look at the costs associated with this technology and the benefits derived to see how it pencils and whether it makes economic sense to do so. So I know I'm talking to mostly Midwest people here, and I guess also a large contingent from Canada. And so you're probably wondering, well, what exactly does a California commercial ranch collaborator look like? And so it's unfortunately, and although this is a quite legitimate photo that was taken in 1949 at the Red Bluff Bull Sale in California, and I love that photo. I think that's fantastic. I don't think they do that sort of marketing anymore. But unfortunately, the California producers really look much like producers throughout the nation. And they are listed here in the next few slides. So the three large commercial ranches we're working with up in Northern California, up in Siskiyou County, actually they call themselves Superior, California. They're right on the edge of the Oregon border and actually prefer to think of themselves more Oregonian than Californian. We've got Jack Cowley, who will be familiar to many of you in the audience. He has about 900 mother cows. He has both a fall and a spring herd. Then we've got the Cook Ranch, which is run by three brothers who fight incessantly every time we do anything with the cattle, so that makes it kind of interesting. And they have also a fall and a spring herd. And then the final commercial ranch collaborator is Mole Richardson Farms, which have a very large fall herd. And all of them are part of the Harris Partnership for Quality program, which is it's a partnership with Harris Ranch, which is a large processor in California. They own their own feedlot and their own meat packing plant. And there's some value sharing amongst producers that belong to that particular partnership. So the actual producers get back some quality incentives if their carcasses grade a certain level of choice and have certain carcass characteristics. And so there's a little bit of market signal there to encourage those producers to seek very good quality products. The fourth ranch that's on there is the UC Davis Ranch, and we have about 300 commercial cattle in the Sierra foothills, and we use mostly Angus bulls, or we have for the duration of this particular project. So all in all then, the ranch resources, you said it would be nice on the Mac, but look at that. As we have about 2,400 total mother cows that are on this project, and over the course of the project, which goes for 3 entire years, so all of the calves that are produced in 2009, 2010, and 2011 basically, we're collecting DNA from those calves, and then we follow the steers and the cull heifers through the Harris Ranch feedlot, and collect their carcass data there, and we also take a sample of meat as they go through processing to do a verification DNA test to make sure we're still talking about the same animal when we're doing our carcass measurements, and that's the database that we've been putting together since this project began in 2009. So at the end of the day, we'll have about 125 Angus bulls that will have some number of progeny depending upon when they came in the trial, because of course they're coming and going as young bulls come in and old bulls go out. So basically the way that this project works is that DNA has been collected on all the bulls and has gone for a 50K whole genome scan, and that's a collaboration with Jerry Taylor and John, originally starting out at Cornell, but of course now here at the Meat Animal Research Centre. So they've all got their 50K whole genome scan. And then in collaboration with the Meat Animal Research Centre here, we're using the molecular predictions that have come out of the weight trait, the 2000 bull project and Mark's large Cycle 7 project that I think Mark will be talking a little bit more about later. We're using some of those predictions to have a look at the molecular breeding values of those bulls trained with those different populations, and we're also looking at equations that have been developed by Jerry Taylor, just using the large Angus 3,500 semen collection he's got from proven Angus bulls, and basically having a look at how all of those different prediction equations evaluate our bulls based on their DNA, and then we're going to have a look at how that compares to how they actually performed in the field in Northern California on these 3 ranches. So the ranch data, and this will be painfully familiar to some of you in this room, is collected on the ranches in close collaboration with Dan Drake, who's a cooperative extension farm advisor or county agent in the lingo of this area. And that might sound like just a little quick thing, it's just one little bullet on the slide, it can't be that much work, but I think we're painfully aware of the fact that's really a big part of this project. And I didn't really appreciate how many times we'd be going to Harris Ranch picking up carcass samples either when we first went out on this project, because all of these steers then go down, and at the cull heifers we get in weights, treatments, and then carcass traits, and we will always be there on a Monday morning at 5 a.m. is when they always do these particular cattle to get the meat sample, and that's been pretty much every Monday morning the last few months. And then finally, we'll compile all this data and compare the 3 sources of genetic estimates. So the breed EPDs, the commercial ranch EPDs, and then the molecular value prediction from a variety of different prediction equations. And that's being done, and I have to give due credit to the PhD student on this project, Christina Weber, who's out actually sampling cattle today, and she's really the workhorse on this project doing all of this work. So when we look at our ranch collection of tail hairs is basically the way that we've approached that. This will look very familiar to some of you in this room that are involved on the weight trait project. We've actually got all our animals EID'd also. I'm not sure if that's part of your protocol, but we just found we had too many number 37s every time we had a calf crop to have any type of just regular numbering system working for us. And so everything's EID'd, and that allows us to keep track at the feedlot too, because then that all gets run on the EID, and then we try and keep track of that carcass as it goes through. Of course, once the head comes off, the EID isn't as useful as it once was. And we also use this little Scion device so we can collect data in the field and match it up with hair samples, because it has a EID reader and a bar reader also. So that all sounds simple and looks like it's all working very well. Well, not exactly. It's taken a lot to get that to work, and we always seem to have computer glitches on the day that we've got all the cattle waiting there and all of the cowboys waiting there. And so some of the problems we've experienced, and I'm sure these won't be unique to California, we get all sorts of interesting tails coming in, and sometimes it's hard to find the hair for the manure that's in the tail. We get some uncooperative animals that just don't want to seem to get their tail hair taken, and we've had a couple of bulls get stuck in the chutes, which has been some of the older bulls as we started this project. I spend a lot of time in the field with my head under a blanket, which might be good, I'm not sure, so I can see the computer screen when we're out in the field, so sometimes that's pretty much how I spend the day. And then finally, I think the most unique animal we had through was this particular animal, which isn't projecting too well here, but it's actually an animal that came through who had no tail. It was kind of a Manx animal, which is a little hard when you're tail hair sampling. And so you kind of, you're collecting and standing there, and then you're like, what's wrong with this picture? So I don't know if it got chewed off or frozen off or what the deal was, but I will tell you that you don't just pull other hair, it doesn't work, because that was what we ended up doing. Not a good plan. Anyway, so we've had some fun. We've got about halfway done at this stage. So this is birth weight, weaning weight, in weight, and carcass trait records. We don't have birth weights on all of those ranches because the commercial ranches and not all of them take birth weights, and we couldn't enforce them to change their management just for us. But we have the most weaning weights, obviously, and we're about halfway done there. We'll have about 7,000 records at the end there when we're done, and then the carcass and in weights, of course, we're only looking at the steers there and the cull heifers. So by the end of the day, we should have about 4,500 carcass data. But at the current time, we're about halfway through that. So, well, what are we going to do with all this data? And I guess I want to echo something that Matt mentioned earlier, and that is we talk a lot about using this data for marker-assisted selection or increasing the accuracy of EPDs. And I think a theme that's becoming more and more clear to me is that in order for this thing to pencil, there has to be multiple applications coming from that single sample of DNA. And I think that there's different uses for DNA in different segments of the beef cattle industry. And if every sector of the industry has to do their own DNA test, it's going to be very hard to make it pencil for each of the different sectors of the industry. And so we're talking about commercial cattle, and I'm going to talk about commercial replacement heifer selection later on today and the uses of DNA to increase the accuracy of those estimations. But one thing I wanted to focus on a little bit here was having a look at the parentage end of the equation, particularly on these large ranches where we have multiple sire breeding pastures. And one thing that just comes out again and again, we've done these studies on 3 different large ranches in, the benefits obviously from a seed stock perspective is the correct pedigree areas. But in these large multiple sire breeding pastures, to have multiple sires, you get higher fertility and the elimination of sire failure and a tighter calving season, and it's pretty routinely used on the larger ranches. But of course, then you can't sort out which calf belongs to which bull. And also it really reduces the need to have 20 cows and a bull in multiple different breeding pastures, and so it it's a lot easier management-wise for the commercial guys. But if you don't have the animals separated, then you can't really have a look at the progeny coming from each bull, and you can basically use the DNA information to enable you to do these commercial ranch genetic evaluations or progeny tests on commercial ranches, if you want to use that terminology. So when we've looked at this is basically the data that came from fall 2009 calving. So this is the first set of data we've got from our from the commercial ranch project. And what this shows is in the blue is all of the calves that were born in the first 30 days of the breeding season. Then the red is the next 60 days, and the green is the late 61 plus days. And we've seen this type of pattern routinely. So here we've got a bull who's got way more progeny, obviously. He's got 46 progeny there, all the way down to one that's only sired 2 progeny throughout the entire breeding season. And the number here refers to the number of animals that got bred in the first 30 days. And of course, that's exactly what you want, is you want to get those calves settled, get the cows settled very quickly. And when we look at this and break it up into, this is not a single breeding group, we'll see this type of pattern routinely, where this is the different pastures with the different bulls in it. And there's always a range of animals or range of calves per bull, and some bulls are doing a fantastic job in the first 30 days and then getting by far the majority of all of the offspring that are born in a particular pasture, whereas others all been through breeding soundness examinations and apparently fertile and sound, are getting almost nobody settled. And this happens to be Cowley's ranch we're looking at here. Here's exactly the same picture for the Mole Richardson Ranch, which is that 700 cow ranch, and their different breedings. But what we find is that from year to year, you won't always see the same pattern, and sometimes some bulls do better one year and the next year they don't do as well. And so although it's interesting to look at retroactively, it's not clear that it's giving you any clear signal if you get that data back what you should do with it in terms of whether you should get rid of, I don't know, this guy, when next year he might be really good. And so we're not seeing much consistency or repeatability in terms of bulls' performance. Of course, they don't always stay in the same breeding groups, and so there's dominance factors come into play. But if you look at it, there's obviously some bulls that are really pulling their weight and producing a lot of money for the ranch. So this was the fall 2009 calving. We went back because we've been working on Cowley's ranch for a number of years and had a look at all of the calf crops sired by two groups of sires that were purchased in two subsequent years. So this is basically the animals that were born in 2004. So these bulls were all born in 2004 and they were purchased in 1 year. And then the blue bulls were all born in 2005. And then they all had 5 calf seasons of access to the cows. So fall, spring, fall, basically. And so if you look at it, these guys had about the same amount of access. And now we're just looking at steer calves that were produced by these bulls, because when we first started this project, we were only sampling the male calves. So we're just looking at steer calves. And what I'm looking at here is the gross income, that is how much carcass value is derived from those steer calves from the Harris payment back to the ranch. And there's just a huge discrepancy here. I mean, the bottom bull was around about $4,500 back to the ranch in gross income from steers, versus this one was up in the $55,000 range of gross income coming back to the ranch. And so these guys, irrespective of any genetic progress, really have a huge impact on the profitability of the ranch. Now, of course, if he wasn't here, some other bull presumably would have taken his place. But it's really quite dramatic and an interesting question as to why you get these sort of variations in the progeny produced by these bulls. So that's what we've found out with regards to the prolificacy. The other thing that we've just started to have a bit of a look at was a preliminary assessment of the commercial tests for beef cattle production traits that are on the market. So the objective of this study was to try to estimate the genetic correlation, so we've heard a little bit about that from Matt, between DNA test results and target traits based on a commercial ranch genetic evaluation of these herd bulls, which was sourced from the Angus seed stock sector. So the companies have discovered these, have had discovery populations where they've developed their tests, and then I guess you could say that they've been validated in the Angus seed stock database, because that's where the correlations are coming from that are being used in genetic evaluations. And then we're kind of one step removed from that, because these are going to be the progeny of bulls that were sourced from the Angus seed stock. And we know there's a relationship between how accurate a test is going to be relative to the relationship between where you're using it and the relationship of those animals to the test where it was actually trained on, or the discovery population. And so we were interested to look, because this is a very typical commercial ranch scenario, to see what the data look like. And so what was done, we basically took the 29 bulls that we had a good number of records on, and in order to enter this particular project, they had to have at least 20 weaning weight records from progeny of their own, and at least 10 carcass records of their own. So these are older bulls, obviously, because we've got carcass data with at least 10 animals included there. And we were basically looking at the MBVs for weaning weight, average daily gain, and that was defined as the weight when they entered the feedlot until kill day, but we didn't get live kill weights. We actually had to back calculate from hot carcass weight because the feedlot doesn't have a live kill weight, and apparently that would have bruised them terribly if we got that particular data point. And so we're working with commercial places, so we went with what we could get. Ribeye area and marbling score. And we basically estimated the genetic correlation between those particular MBVs for those 29 bulls from these bulls, and they've been producing progeny since 2005. So like I say, we're stretching back a little bit in time for these bulls. They're not the more recent bulls that we've been working on. So the description of the records, then we had progeny from the Angus bulls with calf cohorts beginning in 2006. So although the full data set has about 3,500 progeny records, there was only 1,852 that were the direct progeny of these 29 bulls, and not all of the progeny had all of the records. So we had a much smaller number of records for carcass traits than we did for weaning weight. So weaning weight, we were at 1,734 direct descendants of these bulls. So we had a pretty good, some of these bulls had over 100 offspring. And then we had much lower numbers for the carcass traits. And basically the model that was used for the analysis, as Steve will go into a little bit, was basically that the approach that he used, a bivariate animal model, was used to estimate the genetic correlation between the molecular breeding values or the test results and the trait, and also to calculate the eBVs for the bulls. So then with that background then, this is what the results look like. So this is weaning weight, average daily gain, hot carcass weight, ribeye area, and marbling. This is the number of bulls. We only took bulls that had a BIF accuracy greater than 0.05, so they had to have some data for the traits that we were interested in. This is how many direct progeny then were involved in the analysis. And here was the results for the Pfizer product, and this is the results for the Igenity product. And this is the genetic correlations here in this column. But I do want to point out here is the standard error of those genetic correlations. And the first thing I want to say is they're very big standard errors because this is a very small data set. However, they were pretty encouraging, I think, these correlations. There were some high numbers there, even given the fact that we had very high genetic standard errors involved there. If we want to have a look at how that compared to the values that's found when you're looking at the correlations in the Angus seed stock database, that's basically the data that Matt alluded to that's on the Angus website. And on the next slide, I've got those two compared together. So this is the values that's being used in national cattle evaluation in Angus. And what this shows then is the same data I showed on the previous slide, where I've got for the Igenity product here in the green and purple, this is what the ranch estimate was on from the data that we collected with the big standard error bars. So basically, if this standard error bar is crossing zero, we really don't have an estimate that's different to zero, and so we can't have very much confidence in that data. But so obviously this is the one for Igenity, and then the blue and the red here is the one for the Pfizer product. So this is the commercial ranch estimation of that accuracy, and this is the accuracy that's being used by Angus Association when they're doing their national cattle evaluations. And what you see that I think is really positive is it's mostly on the positive side. So that means there is a positive correlation between these, between the genetic estimates, and they're up in, especially for the carcass traits and ribeye area and marbling particularly, where the values were similar to what's been found in the Angus seed stock database. And so for a little validation trial, if you want, or a little assessment with a small number of records, I think this data was quite encouraging. And it suggests that it is quite predictive for the next generation, that is the sons of seed stock bulls that are now going into commercial ranch applications. So why are we so interested in this genetic correlation number? We spend a lot of time talking about it, and we're going to be spending a lot of time talking about it. And I think this slide that was presented at BIF really does a nice job of talking about why we're so interested in this number. And basically, this is looking at the traits that the Pfizer product does predictions on. This is the heritability of the trait. This is the correlation that is being used by the American AGI to incorporate those traits. And this is all in BIF. This is the change in accuracy from 0.05 or parent average that you get as a result of including a genetic test when you've got this type of a correlation. And the things that I want to draw your attention to is if you look here, that the fact that the heritability really affects how much the test helps. So if you have a lowly heritable trait, for example, 0.2 is a fairly lowly heritable trait, then it basically it gives you a large increase in your BIF accuracy of the genetic of your EPD. And it's kind of equivalent to having about 16 progeny records on that particular trait. That's what these approximate progeny equivalents over here means. And you can see that like these two have about the same correlation, but because this is already fairly high heritability, the genetic test doesn't give you as much of a boost as it does for the low tests here, where you get almost double the bang for your buck with the lower heritability traits. And so the genetic tests really help a lot with those low heritability traits. Of course, they're the hardest ones to develop genetic tests for, as Matt alluded to earlier, because you need large training populations to get accurate estimates. But when you've got these numbers high, then you start to get into reasonable increases in the accuracy because you're effectively getting a lot of increase in progeny equivalence, if you will. So let's have a look then. If you just took a heritability of 0.2, so a low heritability, and kept that constant and slowly increased the genetic correlation, you can see when the genetic correlation is down in 0.1 and 0.2, you're really not doing much to help yourself. It doesn't really even generate one progeny equivalent. It's when you start getting up into the 0.5s and 0.6s, which is where the tests seem to be showing up in the Angus validation population, the Angus database. Then you start getting effectively information on an animal at birth that's equivalent to having about 6 to 10 progeny equivalents for these low heritability traits. And that's really where the increase in accuracy from the 0.05 comes into play. Now, of course, if you've got a highly proven bull, you don't get these sort of increases. It's only when we're talking about going from parent average, which is of course what you would have with a young animal that doesn't have any records. They're the type of increases that you can get. And then of course when you get to insanely accurate tests, and I don't think we've got there yet, then you get very big increases in your BIF accuracy and the equivalent of having very many progeny tests there. So that's why we're going to talk a lot about increasing accuracy today, and it's really because once you get up to these types of levels, you really increase your BIF accuracy to where you can actually get a pretty good reading on the EPD from the DNA test. So in summary then, the genetic correlation estimates from this small preliminary data set, and I just want to emphasize that that was a small data set and there's large standard errors, but they were generally positive. They were a little bit lower in general than the values that are being used in the Angus seed stock database, but that's what you would expect because you're one generation removed from that. And they did have large standard errors. And as we keep developing records on this particular large commercial ranch project, this was on 29 bulls. We have about 125 bulls that at the end of the project we should have a good number of records on. And of course we're going to continue to have a look at how well different genetic predictions work as we get more and more data into this data set. So I just wanted to finish up saying that this is really a large collaborative project. We've got participants from the Meat Animal Research Centre here on this grant. We've got participants from the National Beef Cattle Evaluation Consortium, and of course the commercial producers, the processor, Harris Ranch, We've got software collaborators actually from here in Nebraska also, and collaborators from Missouri, and even Mike Goddard in Australia was a collaborator. And I really want to give due credit to the NBCC for putting together those players so that we were able to successfully put in for this grant and start developing this resource population to be used for the validation type work of the different genetic technologies that are out there. So with that, I'll thank you, and I'm happy to take any questions.